All right, so for our last section, last lecture of the year, woohoo, we're going to look at evaluating the summation formula and how to find the limit of that. So you've got all these formulas up here that we're going to use. Yeah, yuck. They look a lot more complicated than they really are. So let me make sure I have all, I'm missing one more. No, there's not a backside. Okay, so on this particular limit, do you mind if I make it really big? Then you'll have to look at the formulas above, right? So if we're going to evaluate the summation of I, and it's 1 through 200, it's really, look at your formulas above. Do you see any formula that we can use for just I? And I doesn't mean imaginary number, oh, by the way. So if you use formula number 2, can't we apply formula number 2? If we're going to find the limit, well, okay, look up here. Here's I, right? Yeah. Okay, so this is no different than this one here, only I have a 200 in place for the n. So instead of having an n, you're going to be given a number. So don't we now know that n is 200? Okay.
So I isn't like...
So I is not an imaginary number. So the question is, why do they use I? I don't know. But they did. All right, so here we go. So I'm going to replace I with n times n plus 1 all over 2. So wherever you see an n, we're going to put in 200. So I've got 200 times 200 plus 1 all over 2. So we've got 200 times 201 all over 2. Can't I divide 200 by 2? So I really get 100 times 201, whoops, 201, and so I'm going to take 201 and tack on 2 zeros to that. And so guess what our limit is?
20,000.
Yeah.
Is this real?
Because if I add up 1 through 200, okay, that's the value. I can actually get a real value answer for that, can't I? And guess what that real value answer is? 20,100. And so that's my limit. It's not going to go any higher than that. All right, so then look at B. They do get a little bit more difficult. Look at B. So B doesn't seem to match anything up there, does it? No. It kind of matches which one? Sort of, kind of matches 3, but not really. So here's what we're going to do in that case. Anytime you have something here in the denominator, because if you look at all of these up here, this means a constant times whatever that number is there. This is a constant in the denominator, constant in the denominator. We'll talk about this in a minute. Constant in the denominator and nothing. So there's nothing in the denominators of any of these, are there? No. So we're going to factor out that denominator out in front. So it becomes 1 over n squared times, and then we have our funky little thing here with a 10 up top, and an I equals 1 here, and then instead I have I plus 2. Well, I still don't have anything there that says I plus 2. Oh, and by the way, I want to put parentheses around all of that. So then we're going to use some properties, and if you look at number 5 right here, if I have something plus or minus something, can't I split them apart? Well, that's what we're going to do. So we've got 1 over n squared times, and we're going to split these apart into 2 different summations. I equals 1 and 10 of I plus so now I can replace I with what we did before, right? So we're going to apply, I can't see that. We're going to apply rule or I don't know, what do you want to call them, formula? formula number, which one for this one? Look above, which one's just an I? So number 2. And for this one, which one's just a constant number?
1.
Number 1. So we're going to rewrite those. So I have equals 1 over n squared times, instead of this whole summation, we're going to replace it with rule number 2, which is n times n plus 1 all over 2, plus, and we're going to replace this whole summation with number 1, which is c times n. What's our c? 2. This is our c. So you might want to write yourself a note that this represents c. So that's where our 2n is coming from, because in rule number 1 is cn, so we take 2 and multiply it by n. Now what's n? 10. In this case, n is 10. Now at this point, if you want to just evaluate it as is, that's fine. Your textbook goes and adds, puts this over 1 and makes them into the same fraction over 2 and combines. I foresee that several of you might have some issues in combining that into one fraction, am I right? So the notes online, yeah, please don't make me do that. So the notes, since this isn't your final answer, I don't have an issue with you leaving it there and then inputting from here. The notes online will show how to convert it into a fraction, which is fine. But instead, we're going to replace n everywhere we see with a 10. Is everybody okay with how I got those? Okay, so then we end up with 1 over 100 times, this is 11 times, and actually the 2 goes into 10 5 times. So this is really 5 times 11, which is 55 plus 20. So 55 plus 20 is what? 75 over 100, because I'm multiplying those together, right? Because this is over 1. What goes into both of those? 25 goes in here 3 times and in here 4 times. So the limit is 3/4. You're really just doing manipulations, and then you're going to have the formulas to look at, and then you have to figure out how can I manipulate this so I can get this formula in there. So your homework, although I've only given you 4 problems, you've got to be able to manipulate it. So let's look at this one. What do you propose that we do with this one? Same thing. So take out that denominator by multiplying it out in front, right? And I'm left with an the summation. Of I plus 2. Are you okay, Zach?
Yeah.
Did I go too fast? Okay. It is. Exactly the same problem with an extra what?
0.
Well, it's instead of putting in, this is exactly the same problem, because if you look at this one and compare it to this one right there, don't I have exactly the same thing? But what's different?
It's 100 instead of 10.
It's 100 instead of 10. So from there, if you want to, since we've already done the work, we've got 1 over n squared times n times n plus 1 over 2 plus 2n. Now put in 100. All the work that I'm showing is the work that you need to show, yeah. I missed something. You have the same answers I do. Yes or no? Is that the answer you have? Are you just not getting the answer and you're waiting for me to do the work? I need to see if you have the same answer.
I got 2140.
Yeah, that's what I thought. So where'd I go wrong?
It's your reducing. You did your reducing.
Are you sure? 5250, right?
Mm-hmm.
Okay. Then my calculator's calculating it wrong. That's what I get for trusting that. Try again. No, this is 105. Never trust your calculator. So now it's 21 out of 40. I knew something was up. All right, so last one. Are we all okay with this? Yes? Last one. So again, what happens with that one? It's the same thing, isn't it?
The infinity.
An infinity. So we still have 1 over n squared times n plus 1 over 2 plus 2n. Here's where it'd be really handy if we actually had the full fraction. Because in order to find the limit, close your mouth. Kelsey's going, what are we going to do here? Because you can't plug in an infinity, right? So we kind of need to know what the actual one fraction is, because that way we can apply those infinity rules from before. So I have a very limited space here. So we're going to take 2 over n, or 2n over 1. And what's the LCD there? For these two? 2. So I want to multiply the top and bottom by 2. So I get 1 over n squared times, I can combine these, so I'm going to distribute, by the way, so I've got n squared, n times 1 is plus n, and then this would be plus 4n. And now isn't it all over 2? Do I have some like terms? 1 over n squared times, I can combine the n and the 4n, so I've got n squared plus 5n all over 2. Now I can multiply, right? So I end up with finally n squared plus 5n all over 2n squared. Can I factor anything out? Yeah, I can factor an n out of both top and bottom. So I've got n times n plus 5 all over 2n squared. Can't this n cancel with one of those? And so now I'm looking at n plus 5 all divided by 2n. So our numerator and our denominator are the same. We could have looked at it here, right? Or here. Either one of those two, the numerator and the denominator are still the same, aren't they? What's the rule for finding the limit as that sequence approaches infinity when your numerator and denominator are the same? The degrees of the numerator and denominator are the same. The coefficient.
Yeah, that one.
So you take the coefficient of your leading terms, and isn't the coefficient here 1 and the coefficient here 2? And same thing here, whether you use this one, the coefficient here is 1 and the coefficient here is 2. So your limit is 1/2. So there are some cases where you are going to have to know how to get it into that one fraction. Really, it's when it's infinity. The other ones you can get by without being able to do that. Now, try not to contain your excitement or anything.